perfect substitutes. Now let us go ahead and in this recording, look at what are perfect substitutes. So perfect substitutes are those goods which can be used against one another. For example, we all know tea and coffee, right? Like for example, Coke and Pepsi. These are the goods which can be used against each other and therefore they're known as perfect substitutes. The question is, how does the curve of perfect substitute look? So for perfect substitutes, we have linear indifference curve. But a linear indifference curve means that the ICs would be straight lines. So you can go ahead and represent the ICs of perfect substitutes as U is equal to AX plus BY. A and B are greater than 0. A and B actually go ahead and it tells us the rate at which we can substitute one good for another. So take an example. Suppose I want to go ahead and I want to hold utility constant at 5. Then I will have 5 is equal to AX plus BY. The question is, we can go ahead and have some values of A and Y given to us. For example, in this case, you can be given A is equal to 2 and B is equal to 1. Now, if that is the case, then you can rewrite this utility function as 2x plus y is equal to 5. Now, what is MRS for perfect substitutes? We know that MRS is given by MUX by MUY, right? We also know that MUX is just differentiate the function with respect to x. MUY is differentiate the function with respect to y. So if I have this general perfect substitute utility function, which is U is equal to AX plus BY, then you can differentiate it with respect to x and you will get A. You can differentiate it with respect to y and you will get B. But note that had it been U is equal to XY, your MRS would have been Y by X. So MRS would have been a function of X and Y's. It would have been a function of your consumption of X and Y. But in this case, MRS is just A by B. So, if my A is 2 and B is 1 in this case, MRS will simply be 2. It will not be a function of X and Y. It will be independent of X and Y. So MRS will be constant, right? So one property of perfect substitutes is that it has a constant MRS, which is independent of X and Y. Now, what does a constant MRS mean? What does a constant slope mean? A constant slope basically means that the person will be willing to give up the same amount of Y for an additional unit of X, no matter how much Y and X he has. So let us just try to contradict this. If you remember in our video, which was about well-defined preferences, where we defined MRS, we said that, look here, consumer has too much Y, too less X. So consumer is willing to give up too much Y for an additional unit of X. He can give a lot of Y for additional unit of X. Right? But now, when you go to point like B, he has very less of Y and too much of X. So he will be giving up very less Y for an additional unit of X. He is going to value Y more here. So how much Y he is willing to give up for an additional unit of X depends on the value of Y and X, whether he has more Y or less Y. That will decide it, right? On the contrary, when we talk about perfect substitutes, it does not matter. Whether I have 10 Pepsi and 1 Coke or 2 Pepsi and 8 Coke, it does not matter. At any point of time, I will be willing to give up the same number of Pepsis for additional Coke because they can completely substitute each other. So the amount of good Y that I am willing to give up for an additional unit of good X, it is going to be the same. It's going to remain the same. This is the property of perfect substitute. Let us try to also plot this beta. So suppose you have 2x plus y is equal to 5. And I want to go ahead and I want to plot this. So we can take some extreme values. Let x be 0. What will be y? 5. Let y be 0. What will be x? 2.5. So x is 2.5 and y is 0. Y is 5 and x is 0. You can join this and you will get your IC. And all your ICs will just look like this then. These are all the ICs. But a lot of ICs together is called indifference map. So this can be indifference map of perfect substitutes. Right? So this is all about perfect substitutes. Okay, thank you.